So in this module, we're going to talk about dynamic mapping templates. This is a new feature that Informatica Big Data Management released in November of last year. So what I'm going to do is give you an overview of dynamic mapping templates, show you how it will improve developer productivity for use cases in Informatica BDM for mass ingestion and handling frequently changing schemas. You should be able to understand the dynamic mapping feature, its use case, and the technical details. You will have a lab where you would build a dynamic mapping template that would incorporate parameterization, dynamic schema input rules, and other features, and be able to run the dynamic mapping with different sources and targets. So at a very high level, right, there's a couple of use cases for dynamic mapping templates. And if you look at the overall data warehousing optimization for Hadoop use case, and you look at the use case for schema on read, you'll realize that there is a lot of effort that goes into building mappings to offload data to Hadoop. And then how do you manage the schema on read concept? So when we talked about it in the intro, right, introduction to big data management, I gave you the process flow of how you would move offload data, your process data, parse data, cleanse data, govern the data, make it consumable for your business analyst or your data analyst. And one of the things that prior to this role, I was in IPS, and we were engaged in a couple of customers that were doing data warehousing optimization, and it was apparent that it was a really tedious job to build out mappings, because we were effectively reusing a lot of the logic that we had built. And we're incorporating, thousands of tables. And, one of the customers that we had about 15 data sources. Each data source had close to about 300 tables that we were offloading, which translates to almost 4,500 tables, right? So, we were tasked to try and figure out how do we offload this data from 5,000 tables to Hadoop, and how do we actually do this in a way that is not time consuming, that will alleviate developers from sitting there day in, day out just building one mapping at a time. So in terms of the process flow, right, again, just a quick recap. I've got my data assets. I've got data that's in OLTP, data that's in ODS, and data that's in data warehouse that I'm going to offload to the Hadoop cluster. Do my transformations on Hadoop, profile, cleanse, parse it, govern the data, and then make it available to the business users, to the end users. Now, what dynamic mapping template allows you to do is to automate the ingestion process, right? So it's building a mapping once and reusing that same mapping, the same logic, for multiple sources and multiple targets, right? So in terms of use cases for data warehousing optimization, you have to look at the different types of patterns, right? So you have to sit and understand patterns within the data. Now, in terms of data warehousing optimization, we had identified two patterns, right? First pattern is going to be your change data capture. on a daily or nightly basis or hourly basis, I don't have the luxury of truncate reloading data for whatever reason, maybe constraints with the source system. But I build a mapping that will do change data capture on Hadoop, right? This is without update strategy, without sequence generator. How do you actually build a logic how do you build a logic for that particular use case? And the second, for particular pattern, I should say. And the second part would be truncate and reload, right? Or if I'm using Hive as my storage layer, and I've got data that's coming in, I can truncate that, load that data, validate, verify that particular data set, make sure it's good before loading it to Hadoop. So, those are the types of patterns that you would identify that would become your template to ingest a lot of this data. And then also in terms of schema and read. So the idea is that, most of us have been in this scenario where, in traditional scenario, right, in data warehouse scenario, where build a mapping, build a solution, say data warehousing, right, change data capture, or CDC type 2s and whatnot. And this mapping goes into production, everything's fine, until the analyst is like, whoa, wait, I realize that in my source system I need to bring in these few columns, and I notice that there's a data type change that I need to make. So what do you do as a developer? You go back and you have to do impact analysis, figure out, okay, I bought this mapping in, it uses a source, it's shared object between a couple of mappings. How do you actually go about applying these changes that could potentially affect multiple mappings, right? So you do impact analysis, then finally you're ready to go implement the changes. You go implement the changes by adding these new fields. Then you got to propagate these fields within the mapping itself, and within the mapping itself, and making sure that you've got the right logic, making sure that you've got the right ports that are coming in, making sure that the target has the right ports and the data types and so forth. So there's no way you would be able to do that task in a matter of reasonable time, within an hour or two. It's something that would take at least a week to 2 weeks, and then 3 weeks to get that back into production. So dynamic mapping templates allow you to take into consideration this the changing schema, the changing metadata, and propagating these changes throughout the mapping. So if you look at, again, that was one particular challenge, right, of a scenario where you implement something, data analyst, business analyst say, hey, look, we need to apply more changes, and you go back and do it. But if you look at from a technical standpoint, right, mappings are tightly bound to schema. There's, if there's anything that has to change, your mapping would have to change. Again, going back to the use case, if there's changes in mappings, changes in metadata, changes in logic, you would have to go back and you'd have to implement that to, who knows, possibly hundreds to thousands of mappings. And then, it becomes difficult to parameterize mappings, right? Because now you have to manage your parameter files, manage your parameter sets, and you have to keep creating these, testing these, and making sure that they're good for production. Now, with parameters, with dynamic mappings, right, the use case is for mass ingestion. And like I said, right, you build a mapping template once, and you reuse the same template across thousands or across many sources and targets with different schemas that automatically adjust, right, to metadata changes to the column characteristics. And if you look at, and we'll go through some of the key features and terminology here, But the main thing is, right, rule-based ports and links, right? You want to bring all the ports in. You can define how you want to bring the ports in. You build a generic source, generic target that will point to your source and target at runtime, and different types of logics that you can incorporate into the mapping itself. So key features, we just talked about parameters in the previous module, and like I said, parameter is one of the main features of dynamic templates, because you could define parameters for sources, targets, transformation logic, and obviously parameter values would change during runtime. So parameters, you define parameters for one object, let's say customer table, but you can redefine parameters for a different table, but again, reusing some of that transformation logic. Dynamic schema, which is the idea or the process of where Informatica BDM, the developer tool, will pick up metadata changes and self-adjust the mapping to pick up the additional or modified columns or remove columns just based on what the metadata is. And in terms of targets, obviously the target can be recreated, replaced at runtime. Input rules define which ports get generated and which ports get created dynamically. Right, so the concept of dynamic ports, and then how do you propagate these ports from one transformation to a downstream transformation. Dynamic ports, again, which transformations are included in dynamic ports, and which transformation go to which transformation within the pipeline. We got dynamic expression. It's basically the idea is that it runs for each port that contains a dynamic port, right? So what that means is, if I have, let's say I have an expression, and in that expression I have logic to validate or check the data types, right? So I have, so let's say 5 columns, 5 ports, and each port's defined as string, and I want to perform a particular cleansing function. So let's say I want to check for if there's any spaces, check for any nulls. If I want to trim these ports that are string ports, I can define that and say, hey, look, for all the string ports that come into the mapping itself, perform this particular transformation logic. And I can define that through dynamic expression. Port selector is pretty interesting, because what I can do is, if I have ports for joiner, lookup, or even dynamic expression, I can define which ports will be used as my join condition, right? So if I'm joining 2 tables, I can identify that 3 of the ports will always be always look for these particular ports and do a join condition on these ports. Same thing with the lookup transformation. Runtime linking is basically grouping ports between transformations, right? And that can be defined at runtime based on the parameter or policy that you create. Dynamic transformation, so a dynamic transformation basically helps the engine identify how to work with different transformations, right? So in an aggregator, we know that, or rank transformation, we know that, the group by port is going to be different based on source. So you can create a port list in the parameter set and define that for aggregator. Same thing like with the sorter, right? So sorter, we know that the sort key is going to different from be different from source to source. So you can define that in a parameter as well, and say that, okay, look, this particular source use this particular key to sort on, right? So same thing with filters. So these are the types of dynamic transformations where the transformation can change based on what the source type is. Okay, so let's run through a few things here. I've identified like 5 different steps to get to use dynamic templates, right? So let's start off with defining a dynamic source. So the way you do this is that in the developer tool, you click on my mapping object, and I can select dynamic schema for relation, right? And if I check at runtime, get the metadata, what that's going to do is it's going to fetch the metadata at runtime from the database and updates that within the mapping. That's how you would be able to propagate any changes, right? So if you're adding any new fields, if you're changing a data type for a specific field, that's how Informatica will make note that, okay, at runtime these changes will be implemented. If you don't check that, then you're going to be using static a static metadata set, right? So again, if you don't use this option, Informatica is not going to know the metadata changes, and the changes will not be propagated to your target. In terms of flat file, now with flat files, you have to define a control file, and this control file is going to contain the headers. It's going to contain the headers, right, of your file. So I can either do that through the control file, or I can specify in my object that this particular flat file already has the headers in there. And you can also handle sources that have different, the order of the columns would be different within each file. So you can also configure that with a flat file, a dynamic schema flat file. We talked about parameters, right? And you could configure, right, if you're using a relational source, obviously you can configure your connection name, the owner name, the table name. So for example, let's take a customer table, right? I have a customer table that's in an Oracle database, and I have a customer table that is in DB2. So in your object, what you would specify is obviously the connection name, the database name, schema name, and the table name. That way, when Informatica goes out there and generates the mapping, it doesn't really care that, okay, you know what, I have, you know, what the metadata would be, because at runtime it'll go fetch that metadata and bring that in. Doesn't matter which database that the object's located in. Again, we're based on how you would, in the second step, you define ports that you want to use, right? So what you could do is you can dynamically tell the engine to load or pass through all the ports that you want to use to the target, or you can combine, or you can create 2 types of ports or port lists, right? One would be one that will be static, where you know that changes will not occur, and one would be dynamic, where you would apply transformation logic to that particular port, right? So if you look here, I've highlighted on the right expression, and the example that I had was, let's say if you have a string set of ports that you're going to be working on, you can actually go ahead and apply transformation logic to the string ports that are coming in. So it doesn't matter what the column is, as long as it's identified as a string port, transformation logic would be applied to those ports that come in. And I have again, it goes back to what I was just talking about, right? So you have the ability to include ports, or exclude ports based on name, data type, or pattern to that particular logic, right? To the particular port set for that particular transformation logic. I can, so if I go back one more, right? So here you'd see that I could have an operator on the right hand side. It says input rules, and I can say include what type of criteria, right? So I can look by type, I look pattern by name. I can, in this example, I said by string. So what the engine will do is it'll pick up all the string ports and say, okay, these are the ports that you have, and what type of logic that you want to go, or what type of logic do you want to apply to it. I can do it by pattern. So let's say if I have a table that has a prefix of, let's say, I don't know, let's say DM, for data mart, or target for TGT for target, I can define rules by that particular pattern, right? So it could be a prefix, it could be a suffix, or I can even do it by a regular expression. And the other thing I would do, right? So remember, we have dynamic ports that would change during runtime based on the transformation logic, and static ports that are pretty much pass through. So I have to specify, I have to tell the engine that, look, if there are any pass-through static ports, you need to include them as pass-through ports. And then you define transformation logic, right? So if you have a joiner transformation, like I said, you could have a port selector where you can specify different ports that would be used as my join condition in the join condition. So it doesn't take all of the ports into the joiner condition, right? You only select the ports that you want to use for your join condition. In the use case I pointed out there, right? So if you get all the ports from the source into joiner transformation and use only a subset of these ports as part of my join condition. Right, so I could set that up. I can set up, like we talked about, dynamic expressions, right? The idea is that I can apply some transformation logic for a number of ports based on the ports that I want to do, right? That I want to work with. Yeah, so again, this is just going back to the different types of transformations, transformation rules, right? So you've got your joiner. We talked about joiner lookup conditions that you can use dynamic ports or parameters where you define port selectors, subset of ports that you use for your join condition. Within the aggregator, remember, because these are dynamic transformations, you would have to define which ports you would only use for group by condition in your aggregator. Same thing with your rank transformation. Targets similar to the way you would define your source and how you parameterize your source object. One thing here would be the mapping flow, right? So what the mapping flow would do is that it will generate the target based on the data object during runtime. You have the option to create and replace the target table at runtime, and you have the ability to bring in all the transformations to the particular object. Runtime linking is the is a feature where you want to bring in all the ports from one transformation to the next transformation, right? So I do not have to sit there and map one column at a one column at a time. Runtime ports would dynamically propagate all the ports, or automatically link all the ports from one object to the other, and based on either a parameter, or it could be on a policy, right? And policy could be like a prefix, suffix, that, hey, look, ignore all ports that have underscore out, right? Or ignore or include ports that have a different prefix, suffix, or expression. Again, just a couple of use cases around runtime linking, right? So the first use case would be sources and targets change dynamically at runtime. So you'd want to use runtime linking to define how ports will be linked at runtime. Second use case, source and targets change completely for a parameterized mapping. So you define it as a runtime linking on how ports from the source to transformation will be linked to the target. And the third case would be transformations that have predefined structure and logic, specifically in the DQ transformations or reusable transformations. You'd use runtime linking to connect these transformations to a parameterized source target with different columns. So, for example, right, so if you have a SSN or you're standardizing a phone number, different sources have different names for social security number, form fields, and you can use runtime linking to link these columns to a fixed column in the, say, data masking transformation or the DQ transformation. Again, runtime linking, right? So we talked about you can do runtime linking by parameters, defining how you would want to connect a source, transformation, and target. We've talked about it through link policy. This is just an example of using parameters as a policy. Oh, as a way to link, as a runtime link policy. I'm not going to go through all of this terminology. I think we've talked about this at the beginning, so you can kind of review this. We do have a lab that will do dynamic mapping templates and parameter set, so that will give you a good handle on how you would develop a mapping that uses dynamic mapping templates with parameters. And I think in that in parameters we'll be dealing with the parameter set. Before we end this module, let me walk you through a mapping that uses dynamic mapping templates and parameters. Okay, so I showed you this mapping in the parameter and parameter set module. So this is the same mapping that that we'll walk through. Let me make this a little bigger here. Okay, so when you do when you design using dynamic mapping templates, I talked about identifying patterns, right? And that's the way you will be successful in developing these or leveraging this feature of dynamic mapping templates. So in terms of big data, first use case was data warehousing optimization for hadoop. And this is prior to 10.0, and like I said, right, we went to a customer wanted to do offloading. We sat down with the customer, we identified patterns within the mapping itself and how you define the strategy of offloading data to Hadoop, and we came down with two patterns. And one pattern was a full complete table refresh. The customer was using Hive as their data store. So one approach was complete refresh of the data sets on a nightly basis, and the second one was change data capture, right? Performing CDC delta detection on Hadoop, similar to, well, almost similar to like a slow changing dimension mapping, right? But we knew that Hadoop has limitations of updating records on Hadoop. So how would you actually go about designing this mapping? So we had to go back to the drawing board and figure out how we would do this. So we came up with this template, and yeah, so we came up with this template that would help us build out change data capture. But again, this was in 9.6.1, and dynamic mapping templates isn't a feature that's part of 9.6.1. It was only introduced last year in 10.0. So, using that as a basis for a use case, created this mapping, and this is a mapping that you use for CDC, right? So, reading stage data would contain today's data. So if I'm looking at today and tomorrow aspect, so this is today's data that's coming in from my ODS or any transaction system. I read data from an HDFS from my target table, and this target table contains yesterday's data. I already talked about parameters, so I'm not going to talk about okay, I can show you the parameters, right? So I have the two tables, right? Today's data and yesterday's data, and I do a join. I look at my join, and it's a full order. Why do we do a full order? Because I want to bring all of the records into. I want to match all of the records. I set up my condition. I can say, okay, this is what my condition will look like, and I'm going to join on these two keys. Now, remember, what we're building here is a shell, right? It's a template, and that template's going to be reused with different sources and different targets, right? Based on my requirements. So that's my join condition that I set out, and I set this as default because it's item and item. And I used item because this is one of the tables that we figured would be used for change data capture. So once I have that, I have to define three things. I have to figure out which is new records. I got to figure out which are new records that need to be updated, and identify records that have no changes. Now, in the Hadoop world, these are all files that we're dealing with, right? This example is HDFS, but it also applies to Hive, right? Because these are all HDFS files. If I were to use my target file as I would use here, I would basically be overwriting that file, right? So I'll be overwriting the original target file, this target HDFS item. So if I look at these three targets, these are temporary files. What these would do is that they would generate temp files, and then I'd have another mapping that, or I could have a union transformation here that would union these three and output it to one file. But for learning purposes, I wanted to call out specifically three files because we'll be loading to three different temp files. So I push my data in, and I have logic that I've set out, right? So I've got logic here, and I said, what's my inset? What do I identify as updates? So if I go back and maximize this, notice here I'm pushing, these are dynamic ports. Dynamic ports because these ports are going to change during runtime. And then same thing here. So then I have a joiner condition, and I'm going to join back my source data and any of the fields that I found. If there's any new, I'm going to write that to a temp file, and then updates, and then no change, right? Now, if I go and look at the expression, I don't think I did it on this one, but it's in the labs where you would actually go and select string ports, and I could do and I can apply transformation logic, right? So this is an expression transformation. Let's go back to the expression transformation. Look at my ports, look at my port selection, right? So what I can do is I have input rules, and I can say here for all based on a type, and I'm going to say the type is string. I'll click OK, and what it does is dynamically it brings back all the string fields. And then I can go and pull logic and decide how I want to work with the string ports. If I go back, I think join a condition, right? So join a condition, I can have a port selector, and I can say, so here I said I created a port selector defined as a pattern that I want to include only fields with the suffix of _DTL. I can go ahead and create a port selector and go back here. What this would do is would say, okay, if there's only fields with _DTL, I'm going to use this as my subset for my join condition. And if I go back, since I've parameterized my join condition, at the next mapping runtime, or a mapping runtime for different sources object, the engine will know to what type of pattern to look for. And again, like I said, I have my parameter sets defined. So if I go back, scroll up, different parameter sets defined for that particular object. I can create parameter sets for different source and targets that I'm going to use within the mapping. Just a quick overview of dynamic mapping templates. There is a lab that you would use that you can work on that will cover a lot of the dynamic templates, parameter sets, features that I've been talking about over the last two modules.